So in this problem, we have a triangle ABC, and it's also given that A times cosine of A equals B times cosine of B. Then we need to show that this triangle is either a right angle triangle or an isosceles triangle. So let us begin. Now what we'll do, first we'll need to specify what does A, the lowercase a, lowercase b stands for. For this, we're going to consider an acute angle triangle. We will consider the vertices as A, B, and C. Now, the side opposite to angle A, which is represented by BC, we will be using lowercase letter a to represent it. Then the side opposite to angle B, which is AC, will be represented by the letter B in lowercase, and side AB, which is opposite to angle C, will be represented by C in lowercase. So this is what A, B, and C stands for. Now we're going to specify the law of sides. The law of sides states that the ratio of the side A to that of sine of the angle opposite to A, so that's going to be A, equals to the ratio of the side B to that of sine of angle B, equals to the ratio of side C to that of sine of the angle opposite to C, which is C. So this is the law of sides. Now what we'll do, we will consider that these three ratios are equals to a constant, so let's call it lambda, such that we can now specify A as lambda times sine A. Then B can be represented as lambda times sine B, and C will be equals to lambda times sine C. Now coming back to our problem, we are given here that A times cosine of A, so that's equals to B times cosine of B. So we'll substitute the value of A and B with the respective values as given here. So we'll get lambda times sine A multiplied to cosine A equals to B times cosine B. So B will be replaced with lambda times sine B times cosine B. Now we can factor out lambda from both sides, and we're going to multiply with 2. So we get 2 times sine A times cosine A. That will be equals to 2 times sine B times cosine B. Now we know for a fact that whenever we have 2 times sine theta multiplied to cosine theta, then this is also equivalent to sine 2 theta. So in our case, we have 2 times sine A times cosine A. So this becomes sine 2A equals to, we have 2 times sine B times cosine B. So that becomes sine 2B. So here we have sine 2A equals to sine 2B. So that means 2A equals to 2B, or we can get 2A equals to pi minus 2B, which means A is equals to B, or A plus B equals to pi over 2. So we have angle A equals to angle B. So whenever we have angle A equals to angle B, then this means that the side opposite to them are also going to be equal. So in our case, A equals to B, this implies that A must be equal, side A must be equals to side B. And whenever two sides of a triangle are equal, then we can say that it's an isosceles triangle. And in the second case, we have obtained that A plus B equals pi over 2. That in sum of the angles of A plus B is pi over 2, which automatically means that the third angle C, that must be pi over 2. So we can say that ABC is also a right angle triangle, right angled at C. Right. So hence we have successfully showed this, that when this given criterion is met, then ABC could be either a right angle triangle or an isosceles triangle.